Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about double integration, multiple integrals. One of our students previously studied intermediate second year. He requested to make some videos. I didn't have time to make the videos, but he keep on requesting to make the videos. That is the reason I'm doing. This is none other than Teja, and one of the best and good student. He requested to make this video. Of course, for some students, by listening this, it is bore, but he did a lot for me. That is the reason I'm making this video. Minimum 2 to 3 videos minimum to get idea on double integration or triple integration. I'm making this video. Let us have a discussion. The first question here. The first question, double integration question I have selected. So evaluate integral 0 to 2, integral 0 to 1, 4xy dx into dy. Observe, dear students, here. First, among xy, with respect to x or y, from which variable you are going to differentiate, that you can keep it first. So the given integral is integral 0 to 2, integral 0 to 1, 4xy into dx into dy. So this is equal to, I am taking, so integral 0 to 2, integral 0 to 1. First, I am doing integration with respect to y. That means here this integral 0 to 1 is there, no? So first you write it 4xy into dx into dy. You remember that whenever with respect to y we are integrating, the rest of the terms we can treat as constants. See, once again I am going to write this integral 0 to 2. So integral 0 to 1 with respect to y I am doing now. So 4x I am treating constant, even dx also. For x dx we can take out integral 0 to 1 y dy. So which is equal to integral 0 to 2 4x dx. Integral y dy means y square by 2, applying the limit 0 to 1. I think you got it. So 4 constant we can take outside of the integral. Integral 0 to 2 x dx. In place of y, substitute upper limit 1 square by 2. So 1 by 2 minus 0. So which is equal to 4 times of integral 0 to 2. Even this 1 by 2 also we can take out x dx, which is equal to 4 by 2 means 2. Integral x dx, x square by 2, applying the limit 0 to 2. So 2 by 2, 2 square, 4 minus 0. So which is equal to 4. Once you go through, dear students, this is the way you can integrate, double integrate. So here integrating with respect to x we are doing. Yeah, we'll move on to the 3 variables. How to integrate 3 variables. In the first question, we discussed 2 variables how to integrate. In this 3 variables, we are going to do the integration. So first, given integral 0 to a, integral 0 to b, this is triple integration, integral 0 to c. The function is in terms of x and y and z, x plus y plus z into dx into dy into dz. So here variable by variable we are doing integration. That's all, dear students. First, integration with respect to x you can start end with dz, or start with dz end with dx. Anything you should do. So here I am doing integration first with dz I am doing. So dz. So with respect to dz means integral 0 to a, integral 0 to b, here keep bracket, integral, before keeping the bracket, with respect to z I am doing now. So dx dy integral 0 to c x plus y plus z into dz. So which is equal to integral 0 to a, integral 0 to b, dx dy. Each and every term you can integrate. So integral 0 to c x dz plus integral 0 to c y dz plus integral 0 to c z dz. So which is equal to integral 0 to a, integral 0 to b, dx into dy. Here with respect to z we are doing no x constant we can take outside, x into integral 0 to c dz, integral 0 to c dz. Here also with respect to z we are doing, so y constant, so integral 0 to c dz. Here with respect to z we are doing integral z dz is z square by 2. I hope you understand, dear students. 0 to c. So integral 0 to a, integral 0 to b, dx into dy, x into integral dz is z, applying the limit 0 to c, plus y into integral dz is z, applying the limit 0 to c, plus c square by 2 minus 0. So we'll simplify here. Integral 0 to a, integral 0 to b, dx into dy, here x into c minus 0, plus y into c minus 0, plus c square by 2. So integral 0 to a, integral 0 to b, here the function is xc plus yc plus c square by 2 into dx into dy. In the next step what I am doing is with respect to y I am taking. So integral 0 to a, here dx I am taking separate. So integral 0 to b, xc plus yc plus c square by 2 into dy. So which is equal to integral 0 to a dx. Each and every term with respect to y we are integrating. So x integral 0 to b xc into dy, integral 0 to b yc into dy, integral 0 to b c square by 2 into dy. So integral 0 to a dx, integrating with respect to y, dear students. So xc we can treat as a constant, xc into integral 0 to b dy, yc integral 0 to b dy. Here c square by 2 is also constant, we can take outside, integral 0 to b dy. So integral 0 to a dx, xc into integral dy is y, applying the limit 0 to b, yc integral 0 to b dy is y, applying the limit 0 to b, c square by 2 integral dy is y, applying the limits 0 to b. Now integral 0 to a dx, here xc into b minus 0, yc into b minus 0, plus c square by 2 into b minus 0. So in the next step, each and every term integrating with respect to x only, no, dx only remaining. So integral 0 to a, first you write it, bcx plus here bcy, next bc square by 2 into dx. So each and every term we need to integrate. So bc constant here we can take out only integral 0 to a x dx plus here also bc we can take bcy also we can take out common y because with respect to x we are doing. So integral 0 to a dx. Next bc square by 2 is constant, integral 0 to a dx. So bc into integral x dx is x square by 2, applying the limit 0 to a. bcy integral dx is x, applying the limit 0 to a. bc square by 2 integral dx is x, applying the limit 0 to a. So bc into a square by 2 minus 0 plus bcy into yeah 1 minute dear students, here integrating with respect to y. Now here I forgot to do here only little with respect to y. Y is I have taken with respect to y means here y integrating. So here y dy students. So y square by 2 here. I'm sorry. Just so b square by 2 will come here. So here it won't come y. So this is b square by 2 only will come. Yeah, here it is okay. Everything is good. Yeah, here also, here y it won't come. B square by c only will come. B square by 2 and x as it is. So b square by 2 into a minus 0. Here bc square by 2 a minus 0. So step by step we'll do it. So here bc a square by 2 plus ac b square by 2 plus abc square by 2. From numerator, ABC is taking common from every term. So if you take ABC, here A is the remaining. By 2 also take common. Here B, here C. Slowly, dear students. Here I forgot to take this. We got it anyway. The answer is slowly you should do. You should not once again, whenever 3 integrals are there, 3 terms are there, slowly one by one, term by term, you can take it. Still any doubts are there, please write in my comment box. I will help you. The next question, dear students. Here, evaluate integral 0 to 2 pi, 0 to pi, 0 to a, r power 4 sin pi d phi, dr, d phi, d theta. Here, observe, dear students, carefully dr, d phi, d theta, and observe the limits also. 0 to 2 pi, 0 to pi, limits in terms of angles are there, no? So, for first two integrals, compulsory d theta, d phi, you can consider. And 0 to a is there, no? Compulsory in terms of r only we can take it. Why? Because these are not angles. So, while writing the integration, integral 0 to 2 pi, integral 0 to pi, whenever 0 to a, integral 0 to a, as it is, first you write it, I will tell the difference. R power 4 sine phi dr d phi and d theta. So here what I am doing is, first two integral contains angles, no? So we are doing the third integration, this integration we are doing. So with respect to r, so the rest of them we can treat as constants. So 0 to 2 pi, 0 to pi, and sine pi d phi into d theta. Keep bracket integral 0 to a r power 4 dr. I think yeah, now you got clarity, dear students, about this. So which is equal to integral 0 to 2 pi, integral 0 to pi, sine phi d phi into d theta. Integral r power 4 means r power 5 by 5, applying the limit 0 to a. So now integral 0 to 2 pi, integral 0 to pi, sine phi d phi into d theta. This is a power 5 by 5. So which are absolutely constant, we can take outside of double integral also. So we can take out a power 5 by 5, integral 0 to 2 pi, keep bracket, integral 0 to pi. Here pi is there, means only sine pi and d pi. The rest all here I am taking. So this integration we are doing now. Integral sine pi minus cos pi. So a power 5 by 5, integral 0 to 2 pi, integral sine pi is minus cos pi, applying the limit 0 to pi into d theta. So a power 5 divided by 5, integral 0 to 2 pi minus cos pi minus cos 0 into d theta. So a power 5 by 5, integral 0 to 2 pi, cos pi value minus 1, dear students, and cos 0 value 1. So minus of minus 1 plus 1, here also minus of minus 1 plus 1, 1 plus 1 2. So 1 plus 1 2 also constant, we can take outside. 2a power 5 by 5 into integral 0 to 2 pi into d theta. So 2 by 5 into a power 5, integral d theta is theta, applying the limits 0 to 2 pi. 2 by 5, a power 5 into 2 pi minus 0. So 2 into 2 pi is 4 pi, 4 by 5, pi a power 5. I hope you understand, students. 4 by pi, 4 by 5 into pi a power 4. We'll move on to the another question. Evaluate integral 0 to pi, integral 0 to a sin theta, here r d theta into dr. Observe, dear students, here theta related is pi, 0 and pi. So in the first in this integral, we need to take r value only. Keep in mind, dear students. So first the given integral 0 to pi, integral 0 to a sin theta or d theta dr. Okay na? So in the first integral only pi is there, 0 to pi. So theta we cannot take, the remaining we can take it. So integral 0 to pi, keep bracket, integral 0 to a sin theta. Here only r dr you can take it in the remaining d theta. So which is equal to integral r dr. Integral x dx is what? X square by 2. Integral r dr means r square by 2. So 0 to pi, this value will become r square by 2, applying the limits 0 to a sin theta into d theta. So now, which is equal to integral 0 to pi, that 1 by 2 we can take outside now. So only r square is there. In place of r, a sin theta substitute. A square sin square theta minus 0 into d theta. Even a square also we can take outside. You will get a square by 2 integral 0 to pi sin square theta d theta. So which is equal to a square by 2 direct integration. Sin square theta is even function, but sin square theta we didn't have. We can apply reduction formula, but in this case most of the students they don't know about a reduction formula. So we will convert in terms of cos. Sin square theta equal to, I'll write here formula, dear students, don't worry about. Sin square theta is equal to 1 minus cos 2 theta divided by 2. We need to remember this. So in place of sin square theta, 1 minus cos 2 theta divided by 2 into d theta. So what we have to do, that 2 also we can take outside, dear students. So a square by 4 integral 0 to pi 1 into d theta. So d theta minus integral 0 to pi cos 2 theta into d theta. Okay na? This 2. So a square by 4 integral d theta is theta, applying the limit 0 to pi, minus integral cos ax sin ax by a. Your doubt will arise. One more formula I will write it, dear students, for your convenience. Integral cos ax dx is equal to sin ax by a. So here sin 2 theta divided by 2, applying the limit 0 to pi. So a square by 4, here pi minus 0, upper limit minus lower limit. Theta equal to pi, substitute sin 2 pi is 0, minus sin 0 is also 0. So ultimately that value goes to be 0. So the answer is pi by 4 a square. I hope you understand it, students. Sin 2 pi 0, sin 0 0. In the next video, I will explain different questions. I hope you understand it, students. Thank you. And those who are B.Tech students, please share this about this channel. This channel is helpful for MCET JEE Main students and intermediate students. Please forward to them. Thank you all.